All right, we're going to talk about inverse functions and relations. So let's start with the definition. Okay, inverse functions. Two functions, let's say f and g, are inverse functions if and only if, IFF, both their compositions are the identity function. Okay. Which sounds complicated, but in reality it isn't. And all that means is if you were to simply go through and do f of g of x, that should equal x, as well as g of f of x should equal x. So in other words, if you were to plug one function into the other, it should simplify down to just be x, and it doesn't matter which one you do. If you do g of f of x or f of g of x, they should both work, and they both have to work in order for them to be inverse functions. So for instance, let's talk about these two. Let's say here's f of x, 6 minus 2x, and g of x is 6 minus x over 2. Are they inverses? Well, in order for them to be inverses, we have to do f of g of x in order to test to see if they are. So I would do 6 minus 2. Now instead of x, I'm going to plug in this 6 minus x over 2. So let's simplify. 6 minus, the 2's cancel, and we're left with 6 minus x. And if you simplify all that, this becomes negative x, or negative 6 plus x, and so the 6's cancel, and there you go. F of g of x equals x. But the other has to be true too, so let's do that. G of f of x. So I would write 6 minus, now instead of x, I'm going to put 6 minus 2x. Don't forget those parentheses, over 2. Simplify up on top, I get 6 minus 6 plus 2x over 2. And so I just get 2x over 2, which is x. So yeah, both of them are. Now, we kind of skipped over this, but let's just talk a little bit about what does it mean to be an inverse. Well, the easiest way to explain it is an inverse is kind of like a mirror reflection. So if you were to look in a mirror and you were to hold up your right hand, what does your reflection have? It holds up its left hand. Well, when two functions are inverses, their coordinates are flipped. If in one function you have the point 6,4, in its inverse you'll have the point 4,6. If you have the point 0,9 in one function, then you'll have 9,0 in the other. Okay, and that's what an inverse function is. Now, we have special types of inverse functions, and one of them would be what we call a one-to-one function. Now, a one-to-one function is simply a function whose inverse, okay, is also a function. Okay, and that doesn't always happen. You might not think that, but a one-to-one function, when we go through and we find our inverse of a function, the resulting equation isn't always a function. And like I said, that's something we're going to talk about actually just right now. So let's move down here. So it says here's f of x. So I want to do a couple things. We're going to find the inverse. Okay, we're going to verify that it is the inverse, and we're going to find the domain and ranges of each. So how do I find the inverse? Well, what I'm going to do is this. I'm going to take my function, okay, f of x, 2x minus 8. And what I'm going to do is I'm going to, remember I said in an inverse, what used to be the coordinates xy, in the inverse is yx. Remember the example I gave was if we had 6,4 as one point, the inverse would have the point 4,6. So the x and y's are switched around. So what we're going to do to find the inverse is we're going to switch around our x and y. So what I'm going to do is where f of x is, I'm going to move this x. And so where x was, I'm going to put f of x. And what I'm also going to add in there is this little -1. Okay, now that's not an exponent there, that's the symbol for inverse. And so that way we remember that what we're figuring out here is our inverse. So my next step then is to simply rewrite this thing so it says the inverse of f of x. So we're trying to get this all by itself. So I'm going to add 8. So x plus 8 equals 2 times this, divided by 2. So I get x plus 8 over 2 equals the inverse of f of x. Okay, there's A. Okay, I just found the inverse. Now, B says verify that it's the inverse. Well, how do you know if it is the inverse? Well, if I'm going to go through and figure out it, then I can go back all the way up here to the top where I said, all right, well, if they're inverses, I should be able to plug them into each other, and they should simplify down to be x. So let's try that. So if I do this part first, f of the inverse of x, so it'd be 2, and then instead of x, I'm going to put this, minus 8. So here the 2's cancel, and I get x plus 8 minus 8, so obviously I get x. Okay, so far so good. Let's do the other one. So the inverse of f of x, so x plus 8, so instead of x, I'm going to put this, all over 2. So I get 2x over 2, so I just get x. Okay, perfect. Okay, both of them worked. So they are inverses of one another. Okay, now the last thing that I'm being asked to do is what are the domains and ranges of the function and the inverse? All right, well, let's talk about, let's just draw a little line right here. Okay, let's talk about f of x right now. What is the domain? Well, what values can I plug in for x, for this function right here? Well, remember that is a line, okay, and is there any x value you couldn't plug in? No, it's all real. Okay, what about the range? What type of answers would you get? If you plugged in any number in here, what kind of answers would you get? Well, you'd get an infinite amount of answers, all different types of answers. And so my range in this case would be all real also. All right, let's talk about my inverse. Let's talk about the domain. Okay, so down here, okay, so my domain, what are some values I could plug in? Well, again, I can plug anything I want into there. There's nothing that would make it undefined. And my range? Well, my range, again, if I plug in any values here, okay, I'd actually get an infinite amount of answers, and they would be all real as well. Now, is that always the case? Do I always get all real for all of those? No, you don't always get that. And we'll talk about an example like that here in just a minute, actually. Okay, so let's talk about that type of example where you don't get always all reals. Well, here's an example of a function. Okay, it just happens to be in the form of a graph. Okay, this is supposed to be somewhat parabolic in shape. Okay, so I want to know what is the domain of, if we call this f of x. Okay, what's the domain? Okay, so in other words, what are all my x values? Well, theoretically, this graph, I don't know if my graph looks like it, but it's supposed to get wider and wider and wider forever. So eventually, it's going to hit every single x value. It might take a long time, but it's going to hit every single x value. So again, this is going to be all real. But what about my range? What are all the different y values? Will it ever come up here? No. So there's definitely some y values that it's not going to have. Well, what are some y values it will have? Well, the first y value that I'll have is this one, which would be at -1, because this point right here is at -3, -1. And then you notice it continues to go in a downward direction. So my y values are all going to be the values that are at -1 and less. And so what you write is this. You're going to write all values of, now normally you'd write x, but we're talking about y. Okay, and since it's a function, we're going to write f of x. All values of f of x such that f of x is less than or equal to -1. Okay, that wasn't awful, I hope. Okay, now let's talk about the inverse. All right, well, what does the inverse look like? Remember, we said that if you have a point like -3, -1 in the original function, in the inverse, you're going to have the point -1, -3. What about this point? This point's at -1, -2. So in the inverse, we should have this point. And what about this point? This point's at 1, 2, 3, 4, 5. -5, -2. So that means I should have a point -2, -5. So just let's take a look at see what those things do look like. If I were to graph it, it'd be -1, -3. It'd be -2, -1. And it would be -2, -5. 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, just verifying that. All right, so it would look something like this. So let's talk about our domain and range. Our domain, okay, that's our x values. So it's, in other words, how far wide is it? Well, you notice here that it doesn't come this way at all. Okay, it actually stops right here. It stops at the -1, and it continues going this direction. So this time, my x value, okay, it'll be all values of x such that x is less than or equal to -1. And now let's talk about a range. Well, this one, you notice, will go up and down. It'll go in an upward direction this way forever, and it'll go a downward direction that way forever. So that means it will be all real. And if you notice, there's a connection. Remember we said if every x value, okay, if you have the point -3, -1, then over here it'll be -1, -3. In other words, the x value here becomes the y value here. If you notice, the domain here becomes the range here. And if you notice that the y value becomes the x. Okay, so in other words, the y value becomes the x. Now the notation's slightly different, but you notice it's basically the same thing. Okay? So that's it. That's our discussion for relations and functions.